into Voice and Its Disorders, which is Chapter 8 in your textbook. Our objectives for today are to review respiration and phonation anatomy, to discuss respiration and the respiration-phonation relationship, and the process of phonation. So when we're looking at oral communication, we're really starting from the bare minimum of oral communication. We're talking about breathing and the phonation, so that air coming in and out of the lungs. And then when the vocal folds close, that air vibrates the vocal folds as it comes out. So looking at it from this way, we have respiration down here at the bottom. That's our breathing, our in and out. And then as we close the vocal folds, that air comes out through the closed vocal folds, vibrating the tissue. The sound that's created from the vibrations of the vocal folds bounces around the resonating cavities, and those sounds are shaped into speech sounds through the articulatory structures. And then we give meaning to those sounds based on our language and the rules for our language. So from a biological perspective, respiration is just the basic exchange of gases for the maintenance of the biological systems. So we have our inhalation, air in, exhalation, air out. But it modifies to meet our demand. So when we're voicing, we voice on exhalation. We can also change our respiration when we're walking. So when we're walking faster, we have to have more air during inspiration. When we're speaking, we also have to have more air on inspiration, and that coordinates with how much we're having to say within a sentence, and it also has to do with if we're doing anything while we're talking. So if you think about when you're talking and walking, your respiratory system can't always support your phonation, your speaking, because it's really trying to coordinate with the movements and the activities during your walk. So for the role of phonation, it's just the sound produced by vibration of the cyclic closing and opening of the vocal cords. And we'll go over the structures of the phonatory system in just a minute. But the overall role of the phonatory system changes depending on the activity. So from a biological perspective, of course, the larynx is there for respiration and helping protect the airway. So ultimately, it comes down to swallowing, protecting the airway while we're swallowing to keep food and liquid from going into the throat. And that happens by closing off the airway or closing the larynx and stopping airflow. And then when we finish swallowing, the vocal folds open back up and we resume on exhalation. During respiration, the vocal folds are open and the air passes freely in and out. And during speech, the vocal folds close again, but not all the way, so that air can be forced through the vocal folds, and that causes the vocal folds to vibrate. So we'll watch this video over here on the right. This is a picture of the vocal folds. And this is when we're looking down through the nose into the throat from above. So it's similar to what we do for the velopharyngeal port, but we're going further down into the throat. So this structure right here is actually the top of the larynx. And then these bands of tissue here are the vocal folds. So when you watch, you'll see those vocal folds come together, and then they're relaxing back to an open state for easy breathing. For coughing, the vocal folds close and open. So they close together to build up pressure below the vocal folds, and then they open slightly so that air can be forced through the vocal folds to expel whatever's in the trachea. So now we're going to go into the specific anatomy for respiration. And for our respiratory anatomy, you have to know where the control comes from, and that is the medulla oblongata, and that's part of the brainstem, right? So the very base of the brain. From a structural standpoint, we have the 12 pairs of ribs that form a cylinder on each side of the rib cage, and that's our primary structural support for respiration. We have intercostal muscles that connect to each of the ribs, and there are two different types. We have internal intercostals and external intercostals, and they have a role in expanding the rib cage to change the pressure within the lungs, or relaxing the rib cage to expel air from the lungs. Of course, we have the lungs that are here underneath the rib cage and housed within the chest cavity. And then we have the diaphragm at the bottom, and that also aids in that pressure change and is really one of the main anatomical parts for respiration. The passive structures for respiration are the trachea, the larynx, the pharynx, the nose, and the mouth. So for phonatory anatomy, we have to know about the larynx and the vocal folds. So looking at yourself straight on, this is where your larynx is in your throat. If you put your hand on your throat, you'll feel a notch kind of just under your chin. And if you swallow, you'll feel that notch rise and fall, and that's your thyroid cartilage. It's the little prominence that juts out. The thyroid cartilage, if we kind of zoom in here, the thyroid cartilage here attaches to the hyoid bone and is suspended by muscle. Now that helps close the airway when we're swallowing and keeps it protected, so it'll lift the airway closed. If we go to a view from above, kind of like what we just saw in that video, then we can actually see the vocal folds. So these are the vocal folds here, the white bands of tissue. And then we have just surrounding structures. And then within here you see the trachea. So when the vocal folds are open, we can see the trachea. When the vocal folds are closed, we can't see the trachea. But this is called abducted vocal folds, meaning that the vocal folds are open or apart. And if they're closed, they are adducted vocal folds, ADD, adducted vocal folds. So the innervation for the larynx comes from the vagus nerve. So it gives motor and sensory signals to the larynx, comes from the brain, and then gives all of the signals down here to this area. And so the larynx is just otherwise known as the voice box. And the larynx is made up of cartilage, muscles, and the vocal folds. So the glottis here, when they talk about glottis, is just the opening between the vocal folds. And that'll make more sense when we look at other pictures. So just to highlight that for you, this is really just the larynx, and this should be familiar to you from the anatomy lecture. So the cartilage of the vocal folds, this is also a review. We have the thyroid cartilage here in the front, and then we have the cricoid cartilage. This is the front of the larynx, this is the back of the larynx. This is the cricoid cartilage, and this is just a small piece of the cricoid cartilage in the front. And then we have the arytenoid cartilage. And the muscles attach to the cartilage, and that's where the names come from. So here underneath each of the cartilages, you have the names of the muscles. So for the intrinsic muscles of the larynx, there are intrinsic and extrinsic muscles. We really only focus on the intrinsic muscles because extrinsic muscles are very delicate and difficult to understand in their role, but we know that it does play a role. We have the thyroarytenoid muscle, and it forms the body of the vocal folds and is responsible for adduction or closing the vocal folds. So if we look over here, it's the one that goes from the front here, from the thyroid, back to the arytenoid. Then we have the lateral cricoarytenoid. It's also responsible for closing the vocal folds, and it's right here. So lateral just means that it's on the side, and it connects from the cricoid to the arytenoid. Then we have the posterior cricoarytenoid, and it's responsible for opening the vocal folds. So it is the lone abductor, and it's back here in the back. It attaches to the cricoid and the arytenoid kind of up and down. We have the inner arytenoids, inter meaning between, so it attaches from the arytenoid on the left to the arytenoid on the right. It's also responsible for closing the vocal folds. And then we have the cricothyroid, and we have to kind of take a different view to look at the cricothyroid. This is a view of the larynx from the side. So this is the thyroid cartilage here. This is an arytenoid. And then we have the cricoid cartilage here. And so this muscle actually attaches up and down for the cricothyroid. And it'll tilt the thyroid cartilage down, lengthening and tensing the vocal folds. So if you think about the thyroid is here at the top and the cricoid cartilage is down at the bottom, it's going to tilt that forward and expand or stretch the TA muscle, or the thyroarytenoid. So when we're looking at our cartoon picture here, this is our view from above of the vocal folds, kind of putting that all together, what we actually see in a person. We have our open vocal folds here, and the space in between is the glottis. And again, it is just a space. It's not a true structure. On this side, we have the glottis here in the middle, and it's open vocal folds. And then on this side, these are closed vocal folds during phonation, so while there's sound being produced, and so you see this little gap in the middle is where the vocal folds are vibrating. All right, so let's watch a quick video about respiration. I want you to imagine that this area down here that he's going to pull down on is the diaphragm, and the balloons are the lungs, and then this globe is the rib cage. So you'll see him pull down and the lungs expand. And then he'll release that balloon, or release the diaphragm, and those balloons will relax. And so you'll see that the diaphragm is really kind of the driving force behind respiration, and it causes a pressure change. So respiration is truly just a change in pressure in order to draw air in through the mouth and expel air from the lungs. So the external intercostal muscles are responsible for moving the ribs outwards, and they're active muscles. That creates negative pressure that pulls the air into the lungs. So negative pressure meaning that there's a lot of space in between the molecules, and there's less pressure in the lungs than there is in the atmosphere. And then it fills the lungs with the air. When the lungs are completely full, we reach inspiratory volume. During exhalation, the internal intercostal muscles compress the rib cage, and this is a passive action. So they actually just kind of relax back down. That creates positive pressure, meaning that the molecules are very, very close together, and that pushes the air back out of the lungs into the atmosphere. All right, so that is the function of respiration. We're going to move into phonation. So if we think about phonation, we'll think about just the sound at the level of the vocal folds, and it simply would just be a buzzing. So what we hear is a combination of phonation, respiration, and articulation. So phonation occurs as the true vocal folds close, and a subglottic or air pressure below the glottis builds up and flows through the closed vocal folds during exhalation. And then the vibrations created by the cyclic opening and closing of the true vocal folds as the air flows through the vocal folds creates sound. So it's just a vibration. So for respiration phonation coordination, we have vocal fold vibrations due to a difference between the positive and negative air pressure change and the elasticity of the muscles. And there's a theory that goes along with that called the myoelastic aerodynamic theory. And that just means that the muscle, the vocal folds, have an active control of tension, and it's impacted by the motion of air and the active forces. So for the subglottic air pressure that blows the vocal folds apart, it causes vibration to begin. And then the air pressure between the vocal folds decreases, sucking the vocal folds back together, causing the Bernoulli effect. And this repeats over and over and over again 100 times per second, which means that sound is essentially just puffs of air released and filtered. Okay, so we can see this in a video. These are our vocal folds on either side, and that air is going to go through the vocal folds. We have our positive pressure here and our negative pressure here. As that positive pressure is released through this negative pressure, it sucks the vocal folds back together, causing the Bernoulli effect. Okay, so that's a cartoon version of it. We'll watch a video of real vocal folds, and you can see the vocal folds coming together. So we have that opening there in between as the air passes through, and they're sucked back together over and over again, creating sound. All right, so we have two characteristics of the voice. We have pitch, number one, which is also known as frequency, and it's measured in hertz. So pitch is essentially just the cyclic vocal fold vibrations, and it's determined by the length, the tension, and the mass of the vocal folds. So you can kind of think of the vocal folds as a rubber band. If we have a very thick rubber band versus a very thin rubber band, the thick rubber band is going to be a deeper voice. A thin rubber band is going to be a higher pitched voice. If we have a relaxed rubber band, then it's going to give us a deeper sound. If we stretch that rubber band out, it's going to be very tense, it's going to have less mass, and it's going to give us a higher pitch. Loudness, on the other hand, is intensity, and it's measured in decibels, and it's a buildup of subglottic air pressure. So essentially, it's like a hot teapot. We're building up the pressure, and as that pressure is released, it increases the loudness as it comes through.